Hello everyone, welcome to week 9 lecture. You must be very busy with preparing your assignment too. Anyway, our today's topic is bivariate statistical analysis, measures of association. You know, in last couple of weeks we are discussing statistical techniques. Last week we also learned about bivariate statistical analysis, but that was the test of difference. Today we will discuss bivariate analysis, again statistical analysis involving two variables, but we will be talking about the measures of association. We will cover chapter 23 today. We have 5 learning objectives today. First of all, we will discuss bivariate correlation. We will interpret a correlation result, correlation matrix. Then we will be discussing regression, simple bivariate regression. We will be discussing multivariate regression next week. We will understand the estimation procedure for regression, least square estimation particularly. And last of all, we will discuss a regression output. So as usual, I will be uploading a separate video on each of these learning objectives. And in this video, I'm talking about the first learning objective. So we start with the basics, measures of association. So what do you mean by measures of association? Measures of association are the statistical techniques that measure association between two variables. So when we say association between two variables, we actually want to mean the strength of relationship, or we say the degree of the association and the direction of relationship. Okay, so a strength of relationship means how strong two variables are related, and direction of association means whether there is a positive relationship or negative relationship. So positive relationship means if one variable changes, other variable changes in the same direction. That is the positive relationship. And negative relationship means when one variable changes, other will change in an opposite direction. That is the negative relationship. So in general, measures of association measure this degree of relationship or strength of relationship and the direction of relationship. We learned about chi-square tests in the last class to show the relationship between two variables. However, we said that chi-square tests, bivariate chi-square tests can be used only if we have two nominal variables. So today we will be talking about the correlation and regression. These are the two measures of association we'll be discussing today, but both of these variables will be applied when you have interval or ratio scale variable. Okay, that means if you say that, well, we learned about chi-square tests in the last lecture, that measures the association between two variables. So why do we need to learn correlation and regression? Because anyway, so correlation and regression, once again, you can say that why we have two measures. Correlation and regression are applied in different circumstances on the basis of different measurement scales of the variable. If we have two variables, then we may look for an or we may look for a dependence relationship between the variables. If we look for an interdependence between two variables, then we use correlation. If we are looking for a dependence relationship between two variables, then we use regression. Okay, so what's the meaning of this interdependence and dependence? If we have, for example, x and y, and we can identify that one of the variables is dependent variable and other is an independent variable, that means there is a dependence-independence relationship. For example, employee satisfaction depends on salary level. So you have two variables, employee satisfaction and salary level. So it's obvious that employee satisfaction is a dependent variable and salary level is an independent variable because salary level determines employee satisfaction. So since we can obviously identify one dependent variable and one independent variable. If we look for an association between these two variables, we will be actually looking for a dependence-independence relation. In this circumstance, we will use regression. Is that one clear? Another example can be like customer satisfaction depends on price level. So once again, customer satisfaction is a dependent variable and price level is an independent variable. There will be a dependence-independence relationship, and we will use regression in this circumstance. Now, if we have two variables, however, we cannot clearly identify which one is a dependent variable and which one is an independent variable, then we look for an interdependence relationship. In this case, neither one is dependent on other. Okay, so we look for an interdependence relationship, and in that case, we use correlation. Okay, let's say that customer satisfaction depends on price level, so that there is a dependence-independence relationship. It's fine, but we have two different variables, that is price level and brand loyalty. Okay, so we might think that the price level of a product and the brand loyalty of a product may be correlated to one another. So in this case, we are not saying that there is a dependence-independence relationship, but we are saying that there might be an interdependence relationship. So in that case, we are using correlation. This is one point. Another point is correlation is used when both of the variables are interval or ratio scales variable. Okay. However, regression is used when your dependent variable is interval or ratio scale. However, your independent variable can be a nominal one. Okay. So I repeat that the requirement for a correlation analysis is that both the variables have to be interval or ratio scales variable. However, for regression, the requirement is that only a dependent variable has to be interval or ratio scale, but the independent variable can be nominal or can be interval or ratio whatsoever. Now, what statistical techniques we use, first of all, depends on the measurement scale of the variable, and then what we are testing or what we are examining. For example, we are finding out association between two variables. So what is the measurement levels of the variable? Is it nominal, ordinal, interval, or ratio? If it is nominal variable, then let's say what we are looking for. Does nationality relate to color preference? So nationality is a nominal variable, color preference is a nominal variable. Since both the variables are nominal, we go for a chi-square test. Now, ordinal, the question is, does importance ranking relate to brand choice? So importance ranking, brand choice. We use chi-square test once again because both the variables are ordinal. Then here, does number of radio spots relate to unit cells? So you have two variables, one is unit cells, another is number of radio spots. So since both the variables are ratio scale variables, we will use correlation or regression. So correlation coefficient. I already mentioned that correlation will measure the strength of relationship and direction of relationship between two variables. Correlation coefficient is a standardized measure of this relationship, and it ranges between -1 to +1. Covariance is also a measure of relationship between two variables, and standardized covariance is basically correlation. That means covariance is expressed in a standardized form, that is correlation coefficient. And as I said that it ranges from -1 to +1. So when it is +1, I mean when it is plus correlation coefficient is positive, we say that there is a positive relationship between two variables. And when correlation coefficient is negative, that means there is a negative relationship. And when correlation coefficient is 0, it means that there is no relationship. Correlation coefficient +1 means there is a perfect positive correlation. So perfect positive correlation means if x variable changes, y will change in the same direction to the same extent. If correlation coefficient is -1, it means that there is a perfect negative correlation. So if x variable increases or changes, y will change in opposite direction to the same extent. That is perfect negative correlation. Now correlation may be less than +1 but is still positive, indicating a positive relationship, and correlation less than -1 but still negative will indicate a negative correlation. This is how we calculate correlation coefficient. So this is if you have two variables x and y, so x bar, we deduct individual x values from the mean and individual y values from mean of y, and we divide them by this part, so we get correlation coefficient between x and y. But we don't need to use this large formula because Excel or other softwares calculate correlation coefficient within seconds. Correlation can also be expressed by this scatter diagram. So you can see that we plot the relationship between two variable x and y, that means a combination of between two variables x and y by these dots. So each dots is a combination of an x value and y value. For example, if you take this point, it's a combination of this x value and this y value. For other point, for example, this one is the combination of this x value and this y value. So each of these dots representing a combination between x and y values, the same as these and this one. Now, if you look at these dots carefully, they indicates a general upward trend. So it's a positive relationship. It also indicates a general upward trend. They are now more condensed, so it indicates a more stronger positive relationship. And this is a straight line, so it indicates a perfect positive correlation. On the other hand, if you look here, it's a straight line and it indicates a perfect negative correlation. Here the dots indicates in general a downward sloping curve, so it's still a negative correlation. But if you look at these dots, they do not indicate any pattern like upward or downward sloping, so there is no correlation between these two variables in this circumstance. Correlation, covariance, and causation. I already have said that the relationship between correlation and covariance is that covariance measures covary between two variables. Like if one variable changes, how the other variable changes, that is covariance. Same thing is measured by correlation, but correlation is expressed in a standardized form. Whereas causation indicates that one variable causes another. We need to make sure one point that correlation or covariance indicates that two variables covary. That means if x changes, y changes. But it does not mean that there is a causal relationship. That means x changes, y changes, that's a correlation, but it does not mean that y change is actually caused by x changes. So correlation is not necessarily an indication of causation. For example, roosters crow and the rising of the sun. So it does not mean that rooster causes sun to rise. Probably roosters crow and the rising of the sun, their time are correlated, but it does not necessarily mean that there is a causal relationship between two variables. If you can remember, probably in lecture 1, we learned that there are 3 conditions that must be fulfilled to have a causal relationship. So that was concomitant variation, that a non-spurious relationship, and there was another condition. You can refer to lecture 1 for them. So if these 3 conditions are fulfilled, then there is a causal relationship. So having only correlation between two variables is not necessarily an indication of a cause and effect relationship between two variables. This is coefficient of determination indicated by R squared. R is actually, if you look at this notation, R, that is correlation coefficient we typically use to indicate correlation. Now, R squared is another statistical term, that is coefficient of determination. If we square the correlation, we get R squared, that is explained variance divided by total variance. Actually, by this R squared, we want to find out how much variation in one variable is accounted by the variation in another variable. Is that point clear? For example, you have two variables, x and y. Now, x is your dependent variable and y is independent variable. So you want to find out that how much variation in y is actually coming from the variation in x, or how much variation in y is accounted by the variation in x. So that will be measured, or that will be indicated by this R squared. Okay, let's say two variables, that economic growth and literacy rate. You think that the economic growth of a country is related to literacy rate. Now, if your economic growth is a dependent variable and literacy rate is an independent variable, and you calculate this R squared, you will actually be finding out how much variation in economic growth is explained by variation in literacy rate. So that is coefficient of determination, or R squared. So this is the end of learning objective 1. We will discuss learning objective 2 in the next video. Thank you.